Infosys provides world-class online IT training, staffing, and software testing solutions to customers worldwide. H2K Infosys, how we are different from our competitors. 100% job-oriented training, hands-on project work, cloud test lab, resume preparation and review, mock interviews, robust syllabus, one-time fee and lifetime access to classes, access to recorded sessions of live classes. H2K Infosys has won the trust of thousands of students worldwide. For a free demo class, visit us at h2kinfosys.com.
So hi guys, good evening everyone. Am I audible to you? Is everyone able to hear me? We will start talking about job scheduling and few other concepts as well. So if you remember, in our previous class we have talked about distributed cache, HDFS, federation, high availability, etc. Right? So for today, hopefully we will discuss about job scheduling and MapReduce chaining, joins, inverted index, and about failures. So these are the topics we are going to cover today. Okay. So by today's class, we would be finishing a MapReduce, and from tomorrow onwards, we will start on talking about pig. Okay. So I don't want to delay anything more. So let's start about job scheduling. So scheduling is a concept of allocating resources in the best possible way among multiple tasks. So Hadoop is a cluster, right? So it's like, in general, it's a very big and of course a very busy cluster. So in that kind of cluster, there will be several tasks running simultaneously. So there will be a point of who will get what, in the sense, for a particular task, how many resources can be allocated, what is the priority that can be given to a particular task, on what basis it can be given. So there will be lot many things coming into picture whenever a task's execution comes in. Right? So Hadoop is a expensive excuse me investment, and rarely it will be used by a single person or group. Most of the times happens. Right? So in the sense, mostly it will be a shared resource. So as soon as sharing comes into picture, contention also comes in. Means who will get what. So the framework has different varieties to the framework has different varieties in order to achieve this. So there are different types of scheduling concepts involved in Hadoop. So the default in Hadoop is FIFO. If you remember, we have discussed once like how the jobs will be executed and what is the full form of FIFO, right? So does anyone remembers it? The full form of FIFO? It's not something new or something particular to Hadoop as well. We have this FIFO scheduler in C and C++ as well. If anyone is aware of, yes. Rahul has given me the answer as first in, first out, right? So as the name indicates, whoever or whatever jobs comes in first, the priority will be given to that job and it will be placed in the queue as soon as it arrives, right? So let's talk about this with an example. Okay, say that, imagine that there are two users, okay, Bob and Charlie or whatever name. So as and soon your Hadoop is installed on your cluster, or if you say that I have installed Hadoop in my cluster, maybe in any mode, sudo mode or distributed mode, once the Hadoop is installed on your cluster, the default scheduler that will be installed is FIFO, and all the jobs will be executed in first out job order, right? So suppose if there are 3 jobs that were that needs to be executed and each job is submitted one after the other, the first job whichever is submitted first will be given high priority, and so on for the second and third jobs. So say that there are 2 users, Bob and Charlie, and we will discuss how the execution happens. One second, guys. Okay. No issues, Prabita. I can share you all the recordings so that you can go through them. Sure, Prabita. Generally, we used to share all the recordings once each of the ecosystem is finished on Hadoop. So hopefully once MapReduce is finished, I will try to share all the recordings so that you can go through that and just get back to me if you have any questions. Okay. Fine. Thank you. Okay. So let's take a case like Monday morning, Bob submits a job that requires 20,000 slots. Just imagine like that. Because in a production cluster, the number of jobs that are going to be executed will be in this way only. Okay, so no surprises. Okay, so this is the case. There are 2 users, Bob and Charlie. The first guy, first of all, comes to office Monday morning and he submits some jobs, and for that particular job to be finished, that requires 20,000 slots. Maybe it involved 20,000 tasks, or maybe 10,000 tasks of maps, and maybe some other intermediate task, maybe reducers. For reducers it required 10,000 slots or something like that. But totally for that job to get finished, it required 20,000 slots. And the second guy, Charlie, is not in office, and cluster has a total capacity of 200 slots. So my cluster might be a small cluster, and it has a capacity of only 200 slots. That means at a single point of time it can run only 200 jobs. Okay. So with default scheduler, all the tasks right. So with the default scheduler, Bob is the guy who first submitted the job, and that's the reason he will get the priority, most priority, and all the 2000 slots will be given high priority than that of the Charlie job. So the execution would be in the format of 200, 200, 200, and so on. All of so this is called as FIFO, and all the tasks of Bob will get scheduled before any task Charlie started. Okay. So but here if you observe, there are few problems, right? So the problems are, first one is a guy may get an option to execute his job, or maybe completely he will be on hold, right? So it's like it's all or nothing. That particular guy can get seat, or maybe he will not at all get the seat. That's it, right? And second one, maybe needed only 4 slots to finish his job, but still he is the second guy to submit his job, and that's the reason time taken to execute his job requires the time of total 2004 slots. So everyone agrees with this statement? So for example, imagine that Charlie has submitted a job, and actually that job requires only 4 slots, but still Bob is the guy who has submitted his job first, and that's the reason Charlie has to wait until and unless all his 20,000 slots have been finished. So Charlie will come into picture only from 20,001 slot only, right? So he has to wait all the time to finish all the 20,000 slots of Bob. But we can queue the priorities here. We can set the priorities. We can set or configure priorities here. But the problem is, what if everyone starts giving high priority? So maybe first of all, Bob submits and he requires 20,000 slots, and maybe after that Charlie arrives and he requires only 4 slots, and Hadoop or the cluster observes it and it gives priority to Charlie. Let's imagine like that. And later on at some point of time, maybe after the second slot of Charlie is finished, some other third guy, maybe Alice, comes into picture and he will submit a job, and maybe it requires only 2 slots or maybe 1 slot. Again, if Alice needs only 1 slot, he might be given more priority. So the priority is used to be changed, and there is no some particular control for the cluster to give this priority, right? So what needs to be done? We can override all these problems of this default scheduler with a better scheduler called as paid scheduler. So this is second kind of scheduler called as phase scheduler. So totally there are 2 kinds of schedulers. The first one is FIFO, which is called as first in first out, and the second one is called as phase scheduler, which means all the jobs will be given equal share. We will discuss about it. Okay. So okay, let me ask you a question here. So guys, whoever are planning to do some certification, these kind of questions will come in certification. So let me ask you. In FIFO, Bob needs 20,000 slots and Charlie needed 4 slots. Right? In the example, this was the case. Bob will have his jobs submitted before Charlie, and is that always Bob's job will so you got my question right? So in our case, Bob needs 20,000 slots and Charlie needs 4 slots. And Bob is the guy who has submitted his job first. So is that the case every time Bob will get executed before Charlie's with the default scheduler? That means the FIFO scheduler, and without giving any priorities. Okay. Rahul is saying yes. So anyone else want to give a shot? I will explain you, okay? No problem. But just try to give. No, just imagine that each guy has submitted one job only. Okay, Charlie has submitted one job and Bob has submitted one job. But the number of slots required for each of the job were different. So for Bob it was 20,000 slots, and for Charlie it was 4 slots. But the number of jobs submitted is only one. Okay. So any other guesses? I want Akshay and Nisha also to give a try. So the reason why I'm asking you the answers is you will remember it. That's the default human. Yes, Nisha is telling yes. Okay, fine. So let's see the case. Okay, let's imagine cycle 1. If you remember, Hadoop, my cluster capacity is 200 slots, right? So let's take cycle 1. So my cluster capacity is 200 slots. In the sense, for all the Bob jobs to get finished, it requires 10 cycles, right? So each time 200 jobs will be submitted. Like that, it will require 10 cycles to finish all the Bob slots required, right? So totally I have 200 in the 10 slots. Yeah, sorry, whatever, 100 cycles. 100 cycles, right? And by default, first 20,000 slots are for Bob, right? So let's take the last cycle of execution. Okay, what happens? Only 200 jobs were left by jobs or left by Bob, and 4 jobs. I mean, if I say jobs, just imagine as slots. Okay, don't confuse with the jobs and slots. I am talking about only one single job. Okay, and 4 slots are left by Charlie. So all good? Do you all accept with this case? In the last cycle of execution, this is the case. 200 slots are left by Bob and 4 slots are left by Charlie. So, okay, once these 200 slots starts executing one by one, maybe after 4 slots are free, in the sense, each suppose there are 200 map tasks that needs to be executed still by Bob, and imagine that after some time some 4 map jobs are finished and still 196 jobs are free. So once these 4 slots are free, what this cluster will do is the remaining 4 slots will be given for Charlie. So now 196 for Bob are finished and 196 are left with him. Now cluster has 4 free slots, and that's the reason it assigns these 4 slots to Charlie. Now, as the number of So, are you clear with this answer? So 196 are left with Bob and But aren't the 200 slots executed completely before being assigned to next job? Yeah, that is what the scheduler is thinking. But what happened is, 4 of the Bob jobs were finished and 4 slots are free. So whenever the cluster see any free slot, it will try to assign whatever the remaining jobs were there, right? So that's the reason it will pull Charlie into picture and it will give those 4 available free slots to Charlie. And the number of tasks that needs to be done by Charlie are very less, only 4. And right now Bob needs 196 slots. So as 4 is less than 196, Charlie's job will get first executed. In the sense, he will get the output first. Simultaneously, Bob's and Charlie's jobs are executing, but still the outcome of Charlie will be soon. Are you clear? Okay. So that is how it happens internally. So we cannot predict like what happens or who will come out first, even though it's a default first in first out scheduler. So let's come back to the next scheduler, that is fair scheduler. Okay, the word fair means equal share. Let's say now there are 3 guys. Okay, Bob, Charlie and Alice, and my cluster capacity is 60 slots. So this is the case I have. So let's take scenario 1. Okay. So let's take the statistics first. Total number of is 60. Does Bob need? How much does Bob need? Tell me, guys. Okay, 300. Right. Alice and Charlie as of now? 0, right? Because they haven't submitted anything. Right. Good. So right now, how much does Bob get? So now for the first cycle, how much does Bob gets? It will be 60, right? So everyone clear with this? Okay, good. After say Bob had completed 240 tasks, or maybe he has finished 240 slots, and the remaining was 60. So only 60 left, right? Now Charlie comes to office and submits a job of 600 slots. So tell me now what happens to this. So how many total number of slots available now? Again, it is a fixed value, right? Because the cluster capacity is 60 and it will be 60 only. And as of now, just imagine initially Bob has asked for 300, right? So let's keep like that. And now Charlie came into picture, and how many he needed? How much Charlie needs for this case? 600. Good. So now as it is equal share, how much Bob gets and how much Charlie gets? Tell me. 60. Right. Good. 30 each. Because it's a fair scheduler, and whatever the slots that were remaining will be fairly distributed between the number of guys who have submitted the job. So as there were 60 left, instead of how many slots they required, the number of slots available will be distributed equally to each of them. And now, after say some time, Elias submits a job and needed 10 slots. So tell me what happens now. So we are clear with this 60. Totally Bob needed 300, right? And Charlie needed 600. We are fine till here. And Elias needed 10. So till here we are clear. Fairness means what should happen in this case? Tell me. Come on, guys. Fair share means what should happen here? The default case. So I'm asking about the right. So fairness means equal share in the sense each should get 20 by default. But this is not the case. Elias doesn't need 20. He is happy only for 10. So what my scheduler, what my scheduler does is, just hold on Rahul 1 second. First it will give Elias jobs because he needs only 10 jobs with whatever 60 that were available. And now once his 10 jobs are given, the remaining number of slots were 50, and now the fair scheduler will come into picture and each will be given equal share of 25 and 25. So this is what it happens. Actually this guy should get 20, but as he doesn't require 20, it will not give all the slots for free because he doesn't need all 20. So it assigns only 10 slots to this guy, and all the remaining slots will be distributed between Bob and Charlie. That's what it happens. And there is some other case also. I will tell you scenario 2. Let's take like this. It's about minimum share. So there will be some hardcore reservation here. Let me explain you, okay? So is the slot always in even number? No, it will not be like that. For easy understanding purpose, I'm taking an even number. That's it. It's not like it will be in even number only. Okay. In general, what I want is I need the best production utilization. Means maximum footage should happen, right? But fair scheduling is not solving that, but it is better than FIFO. If you compare FIFO and fair scheduler is much more better than FIFO, because if you take FIFO, each guy has to wait until the last execution of that first guy or until any free slot is available. But if you take fair scheduler, it is far better than that. Whoever comes into picture, each one will be given equal share. But still, using this fair scheduler also, my production, I'm not getting the best utilization out of my cluster in my production. So for that, they had come up with a new idea called as hardcore reservations or something like that. Okay, I will explain you. So it's like no matter what is happening, each guy should get some hardcore reservations. So let's take a case again. Okay. Monday morning, Bob comes to office and Charlie and Alice are not in office. Okay. So Bob is a very sincere guy, so daily he will come in the beginning. Okay. Bob submits a job of 300 slots. So imagine cluster size is 60. Okay, so the total number of slots available were 60 and Bob needed 300. As of now, Alice and Charlie 0, right? So right now it's a straightforward question. How much Bob gets? It's 60 only, right? He will get all the slots that were available because Charlie and Alice are not into picture still now. And let me paste it. After some time, say Bob has completed 240 tasks and the remaining was 60. Charlie comes into office and submits a job of 600 slots. So let's take the same case what happened in my earlier case. Now what happens is with this hardcore reservation, this remains same, and now Charlie submits a job, so he requires 600 slots.
H2K Infosys provides world-class online IT training, staffing, and software testing solutions to customers worldwide. H2K Infosys, how we are different from our competitors. 100% job-oriented training, hands-on project work, cloud test lab, resume preparation and review, mock interviews, robust syllabus, one-time fee and lifetime access to classes, access to recorded sessions of live classes. H2K Infosys has won the trust of thousands of students worldwide. For a free demo class, visit us at h2kinfosys.com.